Hello, good people of geometry. Welcome to 8.1b. I call it 8.1b because it's just kind of a one little side theorem that's used specifically to solve for the area of any triangle. So you're not limited to just right triangles or anything like that. This is any triangle. This will work as long as you know the three sides. So that's kind of what's important here. Okay, so where does this come from? This is Heron of Alexandria. I'm not sure if that's actually what he looked like. He had an expertise in math and physics. He actually was the first one to come up with a steam engine. He lived 60 years from 10 to 70 AD in Egypt. And he also came up with this formula to figure out the area of a triangle. Okay, this is not important. I just wanted background knowledge. Okay, so here's kind of what it is. Let's walk through it, so don't panic and think that this is a lot to take on. So here's all you do. For any triangle, you take the sum of the sides, okay? So you add up all the sides, divide that number by 2. We call that a semi-perimeter, okay? For short, we call it S. So now to find the area, you take the differences of S and all the sides, multiply it by S, and then take the square root. Okay, so you take the semi-perimeter, so you take everything divided by 2. Then you take the differences of all the sides times S, and then take the square root, and that will give you your area. Okay, so let's look at a few examples, all right, of what we're doing here. So, all right. So I've got a triangle, and I don't know if it's a right triangle, acute, obtuse, whatever. I can maybe make an educated guess here on what it looks like, but I don't know for sure. But it doesn't matter. So all I'm going to do is figure out my semi-perimeter. So I'm going to go 44 plus 50 plus 29 divided by 2. Okay, that's what I'm going to do. I'm going to warn you right now, this is not going to be a pretty number. It's not going to be a nice and easy number, but we can still do it. So that's going to be 123 divided by 2. So that's my semi-perimeter, which is going to be 61.5. Okay, so now this is my semi-perimeter. So now when I go to solve, I'm going to take 61.5, then 61.5 minus 44, 61.5 minus 50, 61.5 minus 29. Okay, so when I do that, 61.5 times 17.5 times 11.5 times 32.5. So I'm going to multiply all those out. So 61.5, 17.5, 11.5, 32.5. So I get a very large number, something in the neighborhood of 40,248.4375. Take the square root of that, 634.23 units squared. That's going to be my answer. That's going to be my answer. Now, I could go into a big, long explanation about why this works and how this works. I'll save you all that. All I want is for you to be able to show me that you can use this for any triangle. And like I said, it is for any triangle that you can think of. All right, now, I know this one was not a very great example. It didn't show it very nicely, but you can see the steps. Figure out your semi-perimeter here, substitute everything in, clean it all up, multiply it, then take your square root for your answer. Okay, so this one, it's a dead giveaway that it's a right triangle, okay? So they tell me, bam, right there. So if I figure out my area, if I can use 1/2 base times height like we were using in the previous section, this time my base will be 33, my height will be 56. These two could be interchangeable. Base times height, height times base. Whichever one you wanted to use. For this one, I'm using this as the base, this is the height. So 33 times 56 divided by 2 is going to give me 924. So now that's my answer, but I want to show you that it works using Heron's theorem as well. So if we do 56 plus 33 plus 65, that will give me 154 divided by 2 equals 77. Okay, so this becomes my semi-perimeter. So now my big formula here becomes 77, 77 minus 56, 77 minus 33, 77 minus 65. So 77 minus 56, so I get 77, 21, 44, and 77 minus 65 should be a 12, and it is. So now those are all the numbers I'm multiplying. So I get square root 853,776. If I do it right, I should get 924, and I do. That's why it works, okay? That's why it works. So I just want to be able to show you that, yes, this does work. Even if I've got, a right triangle, even if I forget that, I can still use Heron's theorem. Okay, so a couple of quick examples here. So just firing through, first part, find your semi-perimeter. So 7 plus 10 plus 12 divided by 2. So plus 7 plus 10 plus 12 is 29, divided by 2 is going to be 14.5. So then 14.5, and then 14.5 minus 12, 14.5 minus 10, 14.5 minus 7. So 14.5, that's going to be 2.5, that will be 4.5, and that will be 6.5. I'm sorry, apologies, that'll be 7.5. So now multiplying everything together gets me, and absolutely do some calculator mashing here, 1223.4375. Square root that, and you should get 34.98. And that'll be my answer, 34.98. Label it unit squared, but that's going to be your area of this thing. Okay, this last one, big, long, ugly decimal. But that's okay. We're okay with decimals. So 5.5 plus 8.5 plus 10.9 divided by 2. Is 24.9 divided by 2, 12.45. So now I do my setup, 12.45. And then I'll kind of skip a step, 12.45 minus 5.5, 6.95. 12.45 minus 8.5 is 3.95. 12.45 minus 10.9 will be 1.55. That's a 5 and that's a 5. So now I multiply all these things together. So that'll give me 529 and 765, call it. So square root that, you get 23.01. And that's my area. That's my area. Okay. All right, so play around with that. Take it step by step. Okay, it can be intimidating if you try and do it all at once, but take it step by step. and I look forward to answering your questions. Thank you.